we can read and then we can multiply 10 to the minus 3 to the base. Okay, there are several types of die and gauge. Okay, this is the die and gauge we normally use. Okay, this is the setup of the unconfined compression gauge. We have two die and gauge, right? We will use a strain control. We can use strain control test or strain control test, depending on how we read the die and gauge. Okay? And this is the swell test. We have this machine. It doesn't work very well. This is another type of die and gauge. This is the die and gauge. There are so many types of die and gauge. Okay, now this called phase. Okay, phase. Die and indicator pointer. It at 9 o'clock. We call 9 o'clock. And spindle, right? Okay, there are two types of die and gauge. The one that rotate to the left, the one rotate to the right. Why is the right and left? Because the soil swell. When the soil swell, it will rotate to the right. If the deformation gauge, it will be on the left, right? It will move to the left. Okay, die and gauge. This one clockwise, counterclockwise. Okay, spindle move down, right? Spindle move down, it counterclockwise. Okay, this is the plate load test of the Saki. If you don't know, look at it. Okay, the textbook sometimes use plate load test. Plate load test is very good to determine. We don't have. We used to have it, but the mechanical stole everything from us to build mini Baja. We don't have it no more. They use the bumper of the truck, and then they jack into the ground. Okay, and then they read the diagram. They know the property of soil. Now, if you put the spindle, right? Suppose the soil swell. The first die and gauge you're going to use will be the swell of soil. Okay, today we're going to bring that one out for you to read. Okay, this one is the swell of soil. Okay, now we look at the small indicator. Okay, this one point. This one is known as the straight gauge. Okay, 0.0001 that we multiply by 10 to the minus 4. We have 10 to the minus 3 and 10 to the minus 4. The small die and gauge between 2 and 3. What should be the reading of this one? It should be what? That means the big needle have gone through 2 times, right? Have gone through 2 times. Then that's why the small one show it beyond 2. And beyond 2, and that's 09, right? Right there. Therefore,
2.09.
the reading should be what?
2.09.
Oh, they don't have it yet. Okay, now look at the detail, the delicate part of the die and gauge. Never oil it, right? Never oil your die and gauge. The bottom can be taken apart. The top one let you know it's about 1 inch movement, right? The vessel, it can be cramped, but don't fool around with it, right? Okay. Right there, show you how to work with the. This is the setup of the proving ring, right? The proving ring is the one that okay, this is the setup, the setup 1 inch, you see that? That means if it deform more than 1 inch and you still crank the soil, you're going to damage the line, right? Damage the machine. You have to stop, right? 12 o'clock, 9 o'clock, okay? When we adjust zero, we always set at the 9 o'clock and then bring it to 12 o'clock, right? 9 o'clock when we adjust. Okay, this one very clear. Okay, the reading of this one will be how much? This is the
6 point.
rotate to the right, therefore it contraction or it measure what? Swell or compression.
Swell.
Swell, right? And what should be the reading?
6.32.
0.001 inch will be what? 10 to the minus 3. The reading will be, the small one will go to 1, 2, 3, 4, 5, 6, right? Therefore, it will be 6 plus what? 6 plus 32, right? Therefore, it will be 632 times 10 to the minus 3. Therefore, it should be what? 0.what? 0.6. 632, right? Okay. You want to take picture of this one? You can. Or you should take picture and print them out and insert into your course pack, you know. In the future, you have to deal with diamond gauge. You can review it quickly, right? And have confidence. Ten, 20, 30, right? It's at 32. And the small diamond gauge, let you know it go by 6 times. Right? Okay, you have it. How about this reading? This reading is what? Still swell, right? The small one go how many times? 4, right? 4 plus what? 25, right?
5.5.
Divided
Or
by
5.
10 to the minus 3, or multiplied by 10 to the minus 3. Oops, they don't have the reading. And this one should be what? This one the same.
5.8.
It will be what? It will be 7 or it will be 6, right? Or 5.
5.
582, right?
5.
Multiplied by 10 to the minus 3. 582 multiplied by 10 to the minus 3. Therefore, 0.582. How about this one?
0.661.
This one is still swell, okay? Measure swell. It will be what?
0.761.
660, right? 661. 661 times 10 to the minus 3. This one, hey, you're wrong. How come it will be 761?
Oh, because that 7's the numbers in between.
Oh, the 0 is a crooked, right? Move to this one tricky, right? We miss by point. You're gonna take picture of this one too? Therefore, this is another type manufactured by a different company. All one. Okay, no detail. Move on. How about this one? What should be the reading?
0.139.
This one just like the last one. It should be what?
139.
It should be what? 139. 139, you're right. This one, you getting good, right? Okay. You getting good. How about this one? this one different, right? This one rotate what?
.684.
Counterclockwise, clockwise, or counterclockwise. Therefore, it will be a 6, right? 680 what? 684. You right? And this one should be what? Should be
514.
526.
514.
514. Hey, oh yeah, I read it wrong. I read 514. Okay, now you have to take care of it, right? You also clean them. This clean them, but never oil them, right? Put them back in the box. Put them back in the box. And okay, now the proving ring. Proving ring normally they use 10 to the minus 4. Okay, it's different. Okay, when the proving ring deform, right, it will give you the load, right? They have to calibrate. They have to keep you sharp, right? When you read the line case, you will have to enter. You see the curve behind the straight line there. Okay, we have that in every proving ring. We have to have 0.001, therefore 10 to the minus 4. What should be this reading? This ring should be 1, 2, 3,
0.03.
3, 1, 304, 304 times 10 to the minus 4, right? Very good. This one should be what? 6 what? 635. You're right, 635. The one you see there should read 10, right? 10, 20, 30, 35, you see. Therefore, this one should be what? 119 times 10 to the minus 4, right? This one should be what?
0.06.
060 what? 060, right? Times 10 to the minus 4. Why this is wrong? I don't know. It should be the pencil is right there. Should be a 2 what? 287, you right? 286, 287. Oh, don't do this, right? Oh, never do this, right? You damage the diamond case. Don't never oil it, right? Because the diamond case don't need oil. You take apart, don't take it apart, okay? Because the dust get into it. Or don't tap it, right? Ooh, that one really hurt, right? If you do that, you damage the diamond case for sure. And this one is poor, right? The mountain not good, right? But we did it anyhow. But this one, oh, don't do it inclination, right? That's bad. And oh, it slipped, right? It crooked, it damaged, right? Okay. Now, what is this for? Oh, when you mount the diamond cage, you have to make sure the leg extend, right? You see the nut there, it can be adjusted, right? To make the diamond cage move. I forgot to ask you how much. Why it becomes 0074, this one? It's 0.074, right? Therefore multiplied by 10 to the minus 4. The reading should be 74. Multiplied by 10 to the minus 4. Therefore it will be 0.0074. And you're not going to take this picture? This one, remember? Okay. This one, picture too expensive. Okay, how about this one, reading? 546. 10 to the minus 3, right? This one, okay, GA, very good production, right?